Welcome to this explainer. Today, we're diving straight into NCP-MCI 7.5, 1.6 security choices at deployment. Now, knowing your infrastructure is awesome, but figuring out how to lock the whole thing down from day zero, that is where the real fun begins.
Here's our roadmap for today. 1. Why deployment security matters. 2. Cluster lockdown and SSH. 3. Lux and SED guidelines. 4. Exam traps and edge cases. And finally, 5. Key facts to memorize.
Section 1. Why deployment security matters. The stakes of day zero. Okay, so when you're deploying a Nutanix cluster, the security choices you make right out of the gate are absolutely foundational. Seriously, they dictate the cluster's entire life cycle. These day zero choices are often totally irreversible unless you want to tear down and rebuild the cluster from scratch. And honestly, no admin wants to spend their Friday night doing a full rebuild just because they missed a security checkbox on Tuesday, right? That's exactly why the NCP-MCI 7.5 exam writers hit these deployment constraints so hard. They want to make sure you don't back yourself into a corner with an insecure or incompatible setup.
Section 2. Cluster lockdown and SSH, securing access.
Before we get into the weeds, let's make sure we've got our baseline vocabulary down. CVM is your controller VM. That's the software layer giving you Nutanix-specific magic like storage and management. Then you have AHV, the Acropolis hypervisor, which is Nutanix's native hypervisor. These two are a team. Now, most of your admin tasks will be done through Prism or REST APIs, sure, but sometimes you just have to SSH directly into an AHV host or a CVM. And that access, it has to be fiercely protected. So let's look at the default setups. You've got your basic password-based SSH authentication. Now, the system does have some built-in safety nets. For example, if you fail 5 logins in 15 minutes, it locks the CVM account for 15 minutes. But for true, rock-solid enterprise security, passwords are just way too vulnerable to brute force. The gold standard is SSH key-based authentication, and that leads us straight to a major feature, cluster lockdown. So what actually happens when you flip the switch on cluster lockdown? Well, it fundamentally changes how you access the system. First off, it completely kills password-based remote login. You're forced to use authorized RSA or ECDSA SSH keys. But here's the massive trap you need to watch out for on the exam. Cluster lockdown blocks password SSH to the CVMs and the HV hypervisor. It does not block SSH to ESXi hosts. Let me repeat that. If you're running VMware ESXi instead of AHV, cluster lockdown secures the Nutanix CVMs, but the hypervisor itself is totally exempt. You'd have to lock down ESXi using VMware's own tools.
Section 3. Lux and SED guidelines. Data at rest encryption. All right, let's nail down 3 critical acronyms you're going to see on the exam for encryption. Lux, which is Linux Unified Key Setup. That's your software-based encryption for configuration data. Then we have SED, or self-encrypting drive. This is hardware-level encryption where the physical drive does the heavy lifting. And finally, TPM, the Trusted Platform Module. Think of it as a specialized physical hardware chip that securely stores your RSA encryption keys. You absolutely have to separate these two concepts in your head for deployment. On the software side, we've got Lux. Nutanix uses Lux to encrypt the underlying OS config data, specifically for AOS and AHV. Keep in mind, it doesn't replace your workload data encryption. On the hardware side, we have our SED architecture. SEDs are FIPS-validated physical drives. All the data written to the disk is automatically encrypted right at the hardware level, using a key management device. Lux is a great addition for strict compliance, but remember, they operate at completely different layers of your infrastructure. Because Lux is software-based, it brings some pretty strict constraints to the table. Let's say a client wants to deploy a new cluster with compute-only nodes to save on licensing, but they also demand Lux. Well, you're going to have to push back. Why? Because Lux encrypts AOS and HV config data, and compute-only nodes don't even run a CVM. On top of that, Lux is only supported on the HV hypervisor, it strictly requires a physical TPM to be enabled, and it's going to eat up about 20 to 30% extra CPU overhead. You've got to verify all of this before you even think about checking that Lux box and foundation. Now, when you switch over to self-encrypting drives, the hardware rules take over. And the field installation guide has a massive, flashing red warning here. If your nodes have SEDs, you absolutely must disable encryption and unlock those SEDs before imaging the nodes with foundation. If you forget to unlock them, you're risking total data loss, and you'll probably completely break your deployment process. To make this crystal clear for the exam, here is the exact procedural workflow you need to memorize. Step 1, disable encryption on the SEDs before imaging. Step 2, image the nodes using foundation. Step 3,
Only after imaging is finished you can enable encryption, but only if the cluster consists entirely of SED drives. Nutanix will not support a mixed cluster when protection is enabled. And that brings us to an unbreakable golden rule. If your nodes have a mix of regular hard disk drives and self-encrypting drives, you can never, and I mean never, enable encryption on those SEDs at any point during the lifetime of the cluster. It's a hard limit. If you want that hardware encryption, literally every single drive has to be an SED. No exceptions.
Section 4. Exam traps and edge cases, the minefield.
All right, time to step into the minefield. Trap number 1, LUKS and compute-only nodes. The exam writers love to give you a scenario where a customer wants maximum security on a cluster that includes compute-only nodes, and then they'll ask you which encryption to apply. Just remember, LUKS encrypts AOS and AHV configuration data. Compute-only nodes don't run a CVM, so their software footprint is entirely different. The rule is absolute. LUKS is not supported if any selected node is compute-only.
Trap number 2 is a classic assumption error. People taking the test often assume cluster lockdown applies universally to every single thing in the physical block. But it doesn't. It applies to the CVMs and the native AHV hypervisor. If a question specifically mentions an ESXi environment, remember that cluster lockdown will secure your Nutanix controller VMs, but the ESXi host itself gets a free pass. It remains totally untouched by this feature.
Here's a really interesting edge case about mixing nodes. Can you physically mix encrypted nodes and unencrypted nodes in the same cluster? Well, physically, yes, you can. But the massive caveat here is that you can only mix them if encryption was never enabled on those SEDs, and it has to remain disabled for the entire lifetime of that cluster. The second you decide to turn encryption on, every single node and every single drive has to support it.
Section 5. Key facts to memorize. The anchor.
We've covered a ton of ground, so let's boil it down to 4 anchor facts you need to have memorized before you walk into that testing center. Number 1, cluster lockdown secures CVMs and AHV, but it skips ESXi entirely. Number 2, you cannot enable LUKS software encryption if you have compute-only nodes. Number 3, to use LUKS, your hardware must have a physical TPM-enabled. And number 4, when deploying nodes with self-encrypting drives, always disable encryption and unlock them before you start the imaging process in Foundation. I'm going to leave you with this final thought. We know that if a cluster mixes standard HDDs and self-encrypting drives, you can never enable encryption on those SEDs. It is permanently off the table. But as infrastructure environments get more hybrid and complex, how are you going to audit your physical hardware layer before a day 0 deployment to ensure you don't paint yourself into that corner? Keep these rules straight, and you are going to navigate Objective 1.6 with absolute ease. Thanks for hanging out with me for this explainer, and good luck on your certification.